Good evening, everyone. As a coordinator and co-coordinator, we all together from GEC Buxar invite Amit Kumar Bhagat sir, as we have told that we requested two industry people to abroad to join in this session. So one industry people from railway services and another, he is Mr. Amit Kumar Bhagat. He is the big data and AI specialist uh, in Europe Baltics. About Amit Kumar Bhagat, he has 10 years of IT experience in designing and implementing scalable data solution, and he is skilled in cloud platform and modern data engineering tools. He is passionate about leveraging big data and AI to drive business transformation. He worked his starting career is started from Sintel as a software engineer from 2014 to 2016, and followed by he joined TCS as a senior software engineer from 2016 to 2018. Then he joined Deloitte USI. It is a big data and technical specialist, and from 2018 to till date, he is working in that firm. And his role is he's taking care, he's leading into in big data solution from design to implement and driving data architecture and solution design for global clients. These are the few things, few roles that I have discussed. Once we will hear the Amit sir, we learn more about that. So Amit sir, Amit sir, are you listening?
Yes, I can listen.
Hand over to you. Please start, sir.
Okay, yeah. Okay, thank you so
Please
much for
unmute,
the.
sir. Yeah.
Can you hear me?
Yeah. We are listening.
Okay. Yeah. First of all, thank you so much for a warm welcome. Okay.
Thank you, sir.
Okay, yeah. Let me just share my screen.
There was his name.
Okay, I hope you are able to see my screen.
Yes, his screen is visible, sir.
Okay, yeah. Okay. Thanks again. And hello, everyone. And a very good evening for everyone who is present here. And I would like to give a big thanks to the coordinator who has just given a small introduction about me. So Anjani Kumar Tiwari, Dr. Anjani Kumar Tiwari, and then the co-coordinator, Dr. Jitendra Pratap Singh. I'm sorry. Seems like I'm just getting confused with the name, but apology for that. And then a special thanks to GEC Buxar for organizing this event. About me, yeah, already it has been covered, but I'll just give a small introduction about myself. So I am Amit, and as mentioned, currently I'm working from Accenture Baltic location, and I have a total of 10 years of experience. And it has been the experience has been around a different technology. So I have worked with the mainframe. If anyone knows about it, it's a very old age technology. And currently, I'm taking care of artificial intelligence. I'm a data specialist. With this, today I'm going to talk about AI in a smart building. This is a very interesting topic, and I hope everyone would like it. So with this, I start my presentation. And before that, throughout the presentation, if anyone has any query, any concern, please feel free to unmute yourself, or you can drop your queries on the chat box and we'll look into this one. Okay, so I'm just going to the next slide. I'm going to hide this. Okay, so the agenda for this session is about artificial intelligence in smart building. So we will be covering the basic of AI and few things related to artificial intelligence. What is Gen AI, which is nothing but a generative artificial intelligence, and will slowly understand how the AI is related to smart building. Also, we'll be talking about what is smart building, its applications, and finally we would conclude with the challenges that we are facing with respect to artificial intelligence in smart building. And at the end we can have a Q&A session where if you have any questions you can ask. Also feel free to pitch in at any point of time. If any slide that is not clear, I'll be very happy if someone unmutes and asks any question. The outcome, or at the end of this presentation, what I'm targeting is at least you will understand what is artificial intelligence, at least some basic of it, and how different things like artificial intelligence, machine learning, or Gen AI, how they are interrelated to each other, and what's the role they play in a smart building nowadays. And then we will talk about some of the real world application that has been implemented. Okay. Now before we straight away jump into the main topic, which is artificial intelligence in smart building, let's understand what is artificial intelligence. Now, wherever or whenever we talk about artificial intelligence, if I break this particular word into two pieces, I'll get artificial and then I'll get intelligence. Now, in a very lame word or in a very simple word, intelligence is something, or it's the ability of a person to do a work or to take a decision without need of any third party or any third person. That's what the basic definition of intelligence is. Now, when I assign this particular intelligence to an individual, which is natural. When I say natural, that means that particular person, maybe if I take a very specific example, it could be a human being. So the human being is born, it's not manufactured. So if the intelligence is associated to any object, any individual which is naturally born, then that intelligence is called natural intelligence. And if the intelligence which is somehow related to a non-human being, it could be a machine, then that's the artificial intelligence. So I'm just giving a very lame example what is a natural intelligence and what is a artificial intelligence. So if I go through a little bit more details, and if I give you a proper example, or the definition of artificial intelligence, then it could be a human ability to to learn something, to adapt to a situation, and to feel the emotion. This is intelligence when it comes to human being. That's a natural intelligence. Now when this same intelligence is mimicked by a machine, by a robot, by use of either the data or by sensor or any algorithm, then that intelligence is called artificial intelligence. uh, Let me take an example. Let's say if you walk into a room and you feel it's hot, then what would you do? Either you would go and open the window, maybe you will try to switch on the fan, or turn on the AC. Now, since you read the temperature, you read the room, you read the condition, and then you decide what needs to be done, that's a typical example of natural intelligence. Now, if I take the same example and apply the artificial intelligence concept to it, that means if I enter into a room or if you enter inside the room, you don't have to do anything. Let there be some sensor, let there be some internet IO things installed, and it will mark my presence, and then it will switch on the light, or maybe it will switch on the fan or turn on the AC. Now, this is what artificial intelligence with respect to the same example is. The second example that I can give about natural intelligence, which we normally see in our day-to-day life, is, let's say, if someone is entering into a restaurant, so there would be a guard, there would be a gatekeeper who would open the door when we arrive. That's natural intelligence. Now, if we would have noticed the big mall, whenever we try to enter inside it, there would be automatic machines or a sliding doors. Now they would have some sensors, and the sensor will mark our presence, and based on that, the door would automatically open or close. That's nothing but a artificial intelligence. So I hope with this slide, everyone has understand what is intelligence, what is natural intelligence, and what is artificial intelligence. If anyone has any question, please feel free to unmute yourself and ask any question. Okay, so I'll move ahead to the next topic, which is what is AI. So we all know AI is like artificial intelligence. So as we discussed in the previous presentation or previous slide, artificial intelligence is nothing but a machine trying to mimic or trying to replicate the human intelligence based on the data it has received. The data can be received by the sensor or some other application. So the artificial intelligence is the stimulation of human intelligence, and it is done by the machine, and especially the computer system we talk about. Now, this artificial intelligence, it can be broadly divided into three phases. The first one is the learning phase. The learning phase is when that particular machine is trying to learn something. Like, let me give an example. So let's say I have a machine or I have a robot, and I'm trying to feed some information to that particular robot. Maybe I'm trying to uh, store data, like what is the cost of a specific flat in a specific place. We can take any example. We can take the example of Bihar, we can take an example of Patna, we can take example of Chennai. So with respect to a specific place, I'm just trying to store what could be the cost of a specific flat on a specific building. That's what a learning is. Now, the reasoning is understanding the data, like the whole place would be a very vast land. Now, trying to understand the data, because the cost of a specific flat in a specific building would differ from a different flat at a different location of a similar place. Now, reasoning is all about understanding the data, trying to relate it. Now, if I say, just Google it out, like give me the average flat cost of a specific location. Now, this is something that I'm not feeding this information to a machine, and it doesn't have any direct answer. If I ask a question, what is the specific price of a flat of XYZ place, this can be given. This is the direct information. But if I'm asking what is the average range of a flat of a specific location, that's not a direct information. So in order to answer it, this machine would have to do the reasoning. So it will try to see the data that I have given, and then it will do some summation, division, like the way we are finding out the average, and then it will give us the output. So that's nothing but the reasoning. Now, self-correction is from time to time, it will correct itself, like uh, during the time. Now, whatever could be the cost of a flat in a specific location, after 5 years, it might not be the same. So self-correction is all about, getting the information from different aspects, maybe taking care of what is the inflammation happening, what is the hike that's happening, what is the demand, what's the supply, and then based on that, the price of a flight would go up or down. So this is all about self-correction. Now, if I talk about the history of artificial intelligence, the idea of artificial intelligence started around 1950s. Now, at that point of time, the artificial intelligence was mostly a theoretical concept. It wasn't any working model. And if you ask what is artificial intelligence in 1950, then someone would say, like, can a machine think? That's the level of artificial intelligence it was present during 1950. Now, if we talk about current situation presently, artificial intelligence is no longer a theoretical concept. We have a working model in so many places, in so many different ways that we are going to see in the next slide. So in this slide, we see how the AI has evolved over the time from just a kind of simple text like AI to now almost like a machine or almost like a human being who is not able to just think, it's able to do the work that any human can do in a much better or a faster way. Now, along with this artificial intelligence, I'm just going to cover some of the very basic words that we normally hear in our day-to-day life, which are somehow a bit similar, and it creates confusion in between ourselves. So three of the basic words that we keep on hearing is AI, then it's ML, and Gen AI. So AI is something that we have talked about a lot. It's just human behavior trying to be replicated by a machine. That's the artificial intelligence. Now, ML is nothing but a machine learning where we are feeding more amount of data to a artificial intelligence type of machine, but now the category is very small. So it's not like I'm feeding all the information to the system. I'm putting the information in a specific boundary, and I'm giving that information to that particular model so that it can give me more accurate answer. So that's a kind of machine learning is under the artificial intelligence, but it's a subset of artificial intelligence. Now, Gen AI is nothing but a generative AI. This is again inside ML, and this is kind of more, how do I say, it's a more specific to a very centric task. So if I give a real life example, the artificial intelligence, I can say a term called doctor. So like doctor, it's a very generic term. That's the artificial intelligence. Now ML could be something like ENT specialist, where uh, ENT specialist is a doctor, but the ENT specialist doesn't look into everything. They have a specific boundary within which they work. Now generative AI could be within this ENT specialist. Again, I can have someone who is specialist just in a very doing a specific work. Maybe the ENT specialist could be generative AI is on the next level, like very much prone or expert in doing operation. So I'm just trying to give a real life example so that we connect with the term what is artificial intelligence, what is machine learning, and Gen AI. And now Gen AI is, again, if I talk in terms of not a generic word, in a very technical world, then Gen AI are the part of the artificial intelligence which do a very specific content creation task. It could be like generating text. So one of the example that I can give is like I have chatbot, I have chat GPT. That's like text kind of conversation. The second thing is image. I can give one more example, which is DAL E. Now it's again one tool and application where it will generate image based on the text that I'm providing. Let me see if I can quickly pull the screen, or maybe I'll take this one in the next slide. Uh, Here, this generative AI board, and here we have the example. The first one is ChatGPT, is example of text-based interaction. The second, we have DAL-E, which is a kind of interaction based on the image. So I give an image, like let's say I want to see a cat dancing in the rain. Then this particular app, DAL-E, it will generate a cat dancing in the rain. The third app that I see here is Music LM. It's again a part of LM or artificial intelligence, and it will generate music for me based on the text or the guidance that I'm providing. So this slide talks about the example or the extension of what we have in the Gen AI concept here: text, image, and music. Now, how does this Gen AI basically work? So everything here works on a concept or the model called LLM, which we say is a large language model. Now, the first step here is, before we construct a model, we feed a very huge amount of data. The way I said, if I'm just trying to have a model and I'll fit or feed all the information related to a specific place, like what is the price of apartment in a specific location, I'm just feeding this data. Now, this is a very small data. If I want to create a LLM model, then it, or let's say like I'm talking with respect to Google, now they would be, they have already fed this information. Now that is the reason, if you Google it out, something like what could be the average flat price in Patna, in Chennai, in Hyderabad, it will give you the response because it has the large data already embedded in it. The second one is a training. Now, training is again, you fine tune your model so that how well it can utilize your data. And third step is the generation step, which is a kind of output that we see. So whatever we type in the Google or whatever we type in the chat GPT, it gives us a response. Now that response is not a kind of original content. It's a fabricated content based on the data that we have provided. Now, since it's a very fabricated, and these informations are taken from different places, from bits and pieces, that's the reason sometimes we say that whatever response that AI or Gen AI creates, it's a original content. So I hope till here we are clear what is artificial intelligence, natural intelligence, and then how these few terms like artificial intelligence, machine learning, Gen AI, and how does it work. If you have any question, please feel free to unmute yourself. And Jitendra ji, I do not have access to the chat message. So in case someone pings any question, please feel free to put that question in front of me. With this, I move on to the next slide. Now, this slide, it talks about the popular artificial intelligence or AI tool that is currently available in market. Now, these all are just 5 or 6 examples that I have put in front because they come from a big tech companies, which is widely known to everyone. But there are thousands and thousands of AI tools which is currently present in market. But we'll just talk about these 4 or 5 types because everything falls into one or the other category. So the first kind of AI tool that we normally see is called chatbot. Now, chatbot is mostly used for asking any question or providing any answer. And this is mostly found when we visit any website. So let's say if you go into any learning platform, if you go into maybe any banking website, so you'll see at the right hand side there will be a pop-up menu or the window that would come like saying, hey, how can I help? That's nothing but a chat bot. It has a very little information with respect to that specific product, and it can help you or it can guide you find what you are looking into that particular website. So this is, I would say, the lowest form of artificial intelligence currently in 2025, that is the chatbot. The second example that's very well known widely is ChatGPT. Now, this is coming from a company or the organization called OpenAI. Now, ChatGPT, again, I'll just break this particular part into two information. GPT is a LLM model, large language model, which I explained in the previous slide. ChatGPT is an example of that LLM model. So ChatGPT is nothing but a LLM model example of uh, you know text-based conversation. Now, if I just give a one-liner, what this ChatGPT is, it's nothing but it's a friend to you who is available 24 into 7. So all you do is you get into Google or any website and just open chatgpt.com. Now, any questions that you ask, it's gonna help you or provide you response like a friend. So this is about the ChatGPT. Now let's go to the next tool that we have in the list is Gemini. Now this again comes from a very well-known organization called Google, and this is mostly used for either doing a chat that's like a text-based conversation if you're trying to search for anything, or if you're trying to analyze like will it rain tomorrow, or any kind of analysis or reasoning that you are doing. So this is very much similar to ChatGPT, but the only difference is one comes from the Google, the other comes from the OpenAI. The second difference, not about just the Gemini, about the Bard as well as Copilot, is ChatGPT has a very huge amount of database. So it has a very, very huge amount of data as compared to the other three examples that we see in the list. That is Gemini, or Bard that's coming from again Google, which is an earlier AI, or Copilot, which is coming from the Microsoft. Now, since the data that has been given to ChatGPT is very huge and the model is very fine-tuned, that's the reason even if you ask the same question to all of these four tools, the ChatGPT will tend to give you more accurate and a very realistic example as compared to other three. Now, moving to the slide, we finally jump to our today's topic about the artificial intelligence in smart building. So we talked or we covered what is the basic of artificial intelligence. Now let's understand what is smart building. Everyone knows what is smart and what is a building. If I put these two words together, a smart building is a building which uses the technology and to optimize its operation, to improve the comfort of the people living inside it, and to reduce the cost of maintenance. If we perform this kind of activity in a building with help of some of the devices, not by using any manpower, then that is called a smart building. The core components that we have in a smart building, the first one is again a very well-known thing, that's IoT device. Now IoT device, it stands for Internet of Things. Now how does it work, or what does it mean? So let's say if I have any physical device installed or embedded in my home that collects some data, maybe with help of some sensor, it collects the data, it sends to the cloud, or it sends to a specific location where there will be artificial intelligence software which will consume that data, read the data, and then it will try to predict or come up with some analysis. That's what the IoT device is. Now we will see how does this IoT device helps in a smart building. The second thing we have in the example is control system. Again, everything is interrelated to this one. So IoT device will be collecting the information. It would be sending the data to a specific location. And then there will be a software that would read the data and then come up with the outcome. Now that outcome could be related to control system. Like how are we going to control a specific operation in a specific building? Could be an example if I say if I have a very huge building. Now during daytime I have an office hour, like it starts from 9 a.m. in the morning till 6 p.m. in the evening. Now instead of doing one thing like before 9 p.m., if the building is like multi-story, rather than having a manpower who goes and then manually switch on all the light, AC, or any other tool, maybe coffee machines, before the people jump into the office. What we can do is, using IoT, these things can be controlled. So the control system is like, we set the office timing, maybe it will read how many people are there inside the room or the building, and then based on this it will control which area of the building needs to be lighted up, which place of this building needs to be have the AC on. Similarly, it talks about the control system, which is nothing but what I explained. And then sensor is all about collecting data and sending it back to the IoT devices. It's about, once the office time is completed, we no longer need that many lights. We might not need the AC to work on a full force. Maybe in the morning it was very sunny, so the AC was needed to be working at the highest speed or the highest temperature. But by 12 noon it started raining, so you don't need the AC to again work in that efficiency as it was working in a very hot and sunny day. So these sensors and IoT, they are interrelated to each other, and it helps in maintaining a smart building. This is again the core component of the smart building, which we talked about in the previous slide as well. We'll go a little bit more details on how they are interrelated. So the IoT are nothing but a physical device. It could be sensors, it could be anything else. But the primary work of the IoT is to collect data from the building. It could be from my apartment, it could be from the corridor, from the staircase, it could be from the uh, boundary area that I have. So IoT sensors are all about collecting data, and then over the network, they send this one to a cloud. Now, either I can send that specific data to cloud, or I can send that data to a building management system which is built. Uh, Normally, if we talk about a very big buildings like we have in Dubai, where we have you know a huge number of floors, that particular building has a building management system. Now, this IoT data, it would be sensor would be reading this data over the network. It will send this data, maybe it will upload to a specific cloud location, or it will put the data, or at least it will make sure that the data reaches this business or the building management system. Now, once the data goes to the specific location in the network, uh, always there will be some software that would run on that data and find out some meaning out of it. And this is nothing but it's a kind of work that we can say it's the AI analytics that is done. So it's like it's reading the data, it's trying to find some insight from the data, so that how it can be used or optimized. Now, once you have all these informations, it will be passed to the next phase, where we say control system or automation. Now, the control system or the automation are the final outcome or the action when it comes to the smart building. So the previous example that we had taken, so let's say in the morning, people started coming to the specific floor. Now the IoT would collect the data, network connectivity will push the data to the building management system, and then the AI would analyze it, and then based on that it will start prepping the whole environment ready to be used. It will start the proper lighting, it will make sure the building is neat and clean. If there is anything wrong, it can, let's say if the building is full and there is some fire, now automation is kind of sending some triggers, some alarms that there is a fire in a specific floor, please don't use the elevator. So these all are kind of either automation or the control system that happens in a very big building in a very smart way. So these all are the core components of the smart building. Now let's talk about little more in details. Like we talked about smart building, how it can be implemented. Now, what is the outcome of this one? So the first outcome that we have here is energy management. So if we implement artificial intelligence in a smart building, the energy management is very optimal, because the light is turned on at a specific point. That means when a person arrives in the room, when person leaves the room or leaves the building, it auto shuts down. Now it's not just about the light. We have many systems that works in a building. Like we have a havoc system where we have a heating that needs to be done. It needs to have a proper ventilation, and it needs to have a proper AC regulation done as well. Now with respect to all these things, there is a huge amount of energy that is lost if things are not managed properly. The artificial intelligence is like, it helps the building to maintain in such a way that it is very energy efficient. Now if it is very energy efficient, the building will be sustainable. You will have a less carbon footprint. That is one of the benefit. The second benefit that we have with respect to AI implementation is security and surveillance. So again, like if I just give a small example, like the United States of America, its defense, or if I take example of a parliament building, now there the security or surveillance is not restricted to eyes, like the forces that is present there. They have the security maintained by the CCTV as well. So if there is an unsuspected vehicle coming through, if there is an unsuspected or unauthorized entry in the building, then this security or the surveillance AI will send a notification to the concerned people to take a specific action. Now again, this adds to the security of the building. The second or the third in the list that we have is comfort optimization. Now I might be giving the repetitive same example, but comfort and optimization is like, uh, let's say if I get into my apartment. Now I'll be the person who would be doing all the activity. Like I have to unlock the door, I need to make sure the light is on, the AC is on. Maybe if I like to have a coffee, I need to start the coffee machine, and then I'll have to wait for a couple of times so that the coffee is ready and I can drink. Now, what if I don't have to do all these things manually? If there is a machine, or if there is a software that takes care of all this activity, like the moment I'm entering into the apartment, there could be some sensor who would read that, okay, I have arrived. In next 10 minutes, I will be in my apartment. So it will start prepping the apartment. It will switch on the AC so that when I enter inside my home, it's not like I'm entering into a blast furnace. So the temperature will be cool. It will be comfortable for me. Similarly, the light, if it's the night, I don't have to blindly find the switch and then turn it on so that I look around the places. It's about the way I'm walking. Based on the sensor, it will detect me, and then it will switch on the light of the specific place where I am currently, and then it will turn up the light which is no longer needed. So this kind of activity is adding more comfort to the people who live in the building, and that's why they are called smart building. The last and the very critical thing about the AI is the predictive uh, maintenance. Now this, I can take one example to explain here, is when we have a very high rise towers, what happens is maintenance of the elevator or the lift is a crucial activity. Now, if that is not maintained properly, there could be an unexpected incident leading to a damage. It could be a damage to a life. Now, if we put a artificial intelligence, and it will have some sensors, that sensor can read how this lift is working. It can read the vibration throughout its working time. It could read the temperature, pressure, tension, all these aspects. And then based on that, it can analyze whether the elevator is working properly or not, or does it need to have any maintenance. So if those data are collected on timely manner, and they are analyzed with given time, then we can avoid failure of any elevator, or we can avoid any incident happening. So things can be fixed before it breaks. This is what is a predictive maintenance about when we add with respect to a smart building. I'll just hold on for a few seconds in case anyone has any doubt, any concern or query. Okay, so silence means no. Moving to the next slide. Now, let's talk about, now we have already talked about what is AI, what is smart, how AI can be implemented. Now let's talk about how the AI has changed from time to time with respect to some of the very smart building implementation. So we can talk with respect to the energy efficiency that has been brought up by the artificial intelligence. Now, couple of things that we have already talked about. HAVAC is something that I talked about. So H stands for heating, V stands for ventilation, and AC stands for air conditioning. Now, if there is a very big building, the HAVAC system needs to be working always in a very optimal way. Failure to have a proper heating could lead to a catastrophic incident. So let's say if you're living in a very cold place, if I take an example, let's say if someone is living at any lab in a North Pole or a South Pole, so think about the temperature there. The temperature is always into minus. There is always snow, and there are a lot of lab or the testing activity going on. Now, if there is a failure of the system and the heating doesn't work properly, now there will be not only damage to the lab, not only to the lives or people living inside it, it will be a huge loss to the R&D that is happening there. So the heating of the building is taken care very seriously. The second example that I can take about, if we talk about the European country, during winter, mostly in the Baltic region, the temperature goes to minus 30. Now, just think if the heating of a building stops working for just few minutes, there will be a lot of people who would lose their life because the heating did not work properly. So that's one example. The second thing is related to ventilation. Now, every big buildings, or if we talk about any proper mining, the ventilation is very much needed. If we do not have a proper ventilation, then again the people would suffocate and die. If you have things, it will rotten and then it will be damaged. Similarly, the AC, if you want to live comfortably, the AC needs to work as per the expectation. So if there is hot temperature outside, the AC needs to match to the temperature. Now, if the temperatures gradually increases throughout the day, then the AC needs to be tweaked, or it needs to adjust the temperature based on the outside temperature. Now again, it's not about just day or night, it's about throughout the year, throughout different season. So the AC needs to work differently when there is sun outside or when there is a moon at the night. The AC needs to work differently when the building is occupied with the full strength, or there is half capacity filled up, or when there is no person inside the building. So this HAVAC system is very crucial for the building or the multi-story building. If you don't have a proper HAVAC system and it's not certified, there are many countries that won't allow you to do the building of they won't allow you to construct your building, because this is HAVAC is not just a feature, it's the life of the people. Next that we have is everything that we talked about, how does this HAVAC system is related to energy efficiency. Now for heating, for ventilation, for AC, all these three activity, they need a energy consumption. Now if the heating is done in a unwanted way, like if I don't need the heating but still the system is working on a very high temperature, I am not utilizing my energy efficiently. Same goes for ventilation. If there are, it's like during the night time, the complete building is shut down because it's an office place. No one is working there. Now, but still the ventilation is working up to its speed. I am simply wasting energy there. Same goes for the air AC as well. If there are no people and still the AC is making the environment very chill, as if the building is occupied with full strength, again I am misutilizing this energy. Now, if we add this problem statement and add the solution as an artificial intelligence to it, then what would happen is the outcome of this would be the energy efficiency will be much higher. We have some use case where I'll show you what's the global statistic says when you add a artificial intelligence to a smart building, what is the percentage of save or what is the efficiency of energy after the AI and before the AI. Now indirectly this AI is nothing but you're trying to improve the energy efficiency, and there are different ways that can be done, which we have already talked about. Predictive energy uses, you predict what is going to happen, and then based on that you take the action. Like I am predicting that, okay, today is Sunday, even it's a 9 a.m. in the morning, no one is going to walk into the building to work. Again, Saturday, it's a weekend and office is closed, maybe Diwali or Holi or any national festival. Even if my office working hour is in between 9 a.m. to 6 p.m., there are public holiday where I don't need to have my havoc system up and running. I don't want any proper heating to be done. I don't care if there is any ventilation. I want the AC to be completely shut down because there is no one in the building to work. So that's like predictive. I'm just predicting, trying to predict what is going to happen. Is it a holiday? It could be a very sunny day, but suddenly it started raining. So I don't need all the system to work to its maximum strength. The second thing is automated lighting and havoc system. Now, automatic lighting is very widely used in European culture. It's not related now. It's not related to just a smart building. It's related to the normal roadway as well. So like instead of having the street light on every time, or instead of having the whole building lighted up like a Diwali when no one is there in the building to work, it's simply a waste of energy. Now you can have the AI installed, a software that would have some sensor. It would read if there are people inside it or not, and then based on that it will turn the light on and off as per the requirement. Now the third point that I see is renewable energy integration. Now, not very much in India, but if we talk about different places, the building doesn't have to typically depend on the uh, energy that is provided. It can use on a renewable energy concept. It can work on a renewable energy concept. So let's say if you have a big buildings, you can install a solar panel on the top of the roof that would just take care of basic minimum work. Like it will just have a light lukewarm water so that you can use it in your day-to-day activity. The renewable energy, again, it can be used, and you can have a very well optimized lighting. Like instead of using halogen bulbs, you can go through LED. And then using this renewable energy, what we can do is we can use to light up the building. Everything here, if I'm not using the typical energy that is coming to the building, I'm generating the building, that's a renewable energy, and then I'm using it inside the building. Indirectly, what I'm trying to do is I'm improving the energy efficiency of the building. I hope this is making sense. Okay, now moving to the next one. Now, how does this artificial intelligence plays its role in security and surveillance? Now, the first thing is the AI can be used as an intelligent CCTV with object detection. So again, if I take a place which needs to be guarded, like we have the parliament, like we have the US Pentagon, or any places that needs to be secure, then this intelligent CCTV is installed there, and if there is any suspicious activity, then what it will do is it will detect and it will let you know, or maybe it can inform the security about this specific incident going on, and then the person can take a deep look to find out what exactly is going on. The second thing is intrusion detection. Again, intrusion detection is about someone who is not authorized to enter a building, and he tries to forcefully enter the building, maybe through a, like stealing someone else's smart card, punching through the system, and then entering the building. Now, even if you are holding the smart key, but you are not the person who to whom this particular smart key belongs to. So you can have some facial recognition done there, where when the moment you are punching the card and you are moving around the building, it will try to capture your face and then try to find out, are you the correct person or the owner of the card? And that can be used to find out whether you are trying to enter the building without a proper permission. Now, the third example, or the third role that AI plays in the security surveillance is the automated alert. Now, this is a life-saving work that artificial intelligence is doing nowadays in a very big buildings, or we say smart buildings. One of the example which I gave is, if it's a multi-story building and there is some issue at a specific floor, this automated alert system will send messages. One, it can send message to the fire brigade, so that XYZ building has some fire and immediate help is needed. So that's one kind of automated alert that is sent. The second is, it can send the similar information to the building management system, or to the building management group, or the security, to take a immediate action. The third one is, it can inform the whole employees or the people near around the building to stay away from a specific location. So alerts are all, is like, either there is a incident that has happened, and before it becomes very huge, the alert help you to minimize the impact of the small incident that has happened. And sometimes the alert can help you overcome, or completely remove the failures, the way we talked about in case of the elevator. So if I have a proper sensor working with respect to the elevator, before, sometimes what happens, the elevator, they breaks. Now, before it breaks, the AI with combination of the IoT, it can predict whether this lift is going to malfunction or the lift is going to break, and then it will not operate even if you are trying to enter inside the lift, and then pushing the button that I want to get into the 100th floor. It won't accept your command, because it knows that, okay, no, there is something wrong with this particular lift. And unless or until the security, or the maintenance people, they come and check and then reset this particular alarm, it cannot be used. So these small things plays a very crucial role when it comes to security and surveillance. Moving to the next one. Okay, there is one thing that I missed in the previous slide. So along with all these operations, we see here a email box kind of thing. So every time we come across all these three kind of issues, like the object that has been detected, or someone trying to enter the building forcefully, there is something wrong. Along with sending some alert, email can be sent, or a text message can be sent. Now this would help the team to be proactive, and then they can start looking into the particular issue. Let's go to the next slide. Okay, now this is something, again, we'll talk about more in the predictive maintenance, and how does it helps in maintaining the building. The first one is, predictive means, as we talked about, trying to find out things that might go wrong or something has just gone wrong, and before it has a very catastrophic impact, let's stop it. That's all about the predictive maintenance about. Now, how does it help? Now, if we try to have the maintenance before it completely breaks down, what it will do is the equipment health monitoring system uh, that is implemented using the AI, it will help to have all these machines make the life longer. Like whatever, if I have the elevator, if I have any other system, if the proper monitoring is installed, then the lifespan of that specific object or the specific machine tool will be longer. The second one is the moment you predict the failure, we avoid any unwanted or any unwanted damage that could have caused because of the failure. The third option that I see is reduced downtime. Now, let me take this similar example of the elevator. Now, the first scenario is where the elevator is working fine, there is no AI installed, and some point of time the elevator completely breaks. Now, there are a couple of things that would be happening. The moment the elevator is broken, it's not working properly, someone would have to find out that the elevator is not working. The next thing is the same information needs to be passed on to the correct person. So either it goes to a security team, it goes to the guard, or it goes to a building maintenance group. So the information needs to be passed. Now, since the failure happened, there could be the reason that more damage was done. Now, with all this thing, the downtime, that means the time in which the elevator can be up and running, is very high. Now, in the second case, let's say if we have added AI into this, there could be two scenarios here. The first one is the AI detects before the failure, it sends the message to the team, and the team arrives on time. It will just do the maintenance or the regular checking, and then if it needs to be fixed, it will fix the issue. And maybe, the artificial intelligence, it can somehow give the exact information as well, that I hear some noise in the motor, maybe the winding has gone wrong, or maybe I feel more vibration during the lift when it goes up or when the elevator is coming down. So based on that, the maintenance team would be coming with the proper response or proper remedy to fix it. So this is like, it's reducing the time, so it's like it reduced downtime. The second example could be uh, that let's say the artificial intelligence, it could not predict the failure because the failure happened in a very short span of time. But still, the moment the elevator breaks down, it will automatically start sending the emails that we talked in the previous slide. So it will start sending direct email, maybe with a very high notation like action needed, or it's a priority one email, to the direct individual person who is responsible for maintenance. So we don't have a person or a postman who carries the information from one place to the targeted place and delivering the news that the lift is broken. It's just a single click. The AI will find out that it's not working, and it will send the email with the proper details. Now the maintenance team would come and then they fix it. So the whole point here is, if we have AI installed in this situation, it will have a very reduced downtime, and this somehow, adds to the comfort of the people who lives in the building, which could be the next slide. Now, this is one of the interesting concept which is very widely used, mostly when it comes to uh, a high-rise building, mostly in the Dubai, or in the United States, where we have a very world tower kind of. I see a message, can't start video because stopped by host. Jitendra ji, can you confirm if everything looks fine? Hello. Can anyone confirm if they are able to hear me loud and clear, please?
Yes, sir.
Yes, sir.
Okay, yeah. Yeah. Thank you so much.
Yes,
Okay,
sir.
now going back to a new concept, that's like artificial intelligence plus digital twins. Now we all know what is twins. Now if we twins are like two uh, things or buildings which are similar in nature. Now digital means the one building is physically present, the second one is digitally present. So it's like you scan the physical building, construct the 3D model of that particular building, and that we call as a digital twins. Now why do we need this digital twins, and how is the AI related to it, and how it is being used? So if I say I have a very big building, maybe Burj Khalifa, or building that has like thousands, not thousands, maybe hundreds of floors, and we all know that the building needs to go under maintenance, under renovation. It could be like breaking some floor, or maybe some part of the building, and then trying to have construction that would increase the strength of the building. Now what if or what if without doing a proper R&D, we decide that a specific part of the building needs to go under renovation, and we start breaking things and then fixing things. Now during this process, we recall, or we understand, or we get to know that by doing the activity called renovation of a building, we have accidentally done something that is making the core strength of the building weak. Now in order to avoid this kind of miscalculation and mishappening, what we do is we apply AI plus the digital twins. So let me talk about this. So digital twins is nothing but a virtual representation of a physical building and its system. And this is like in real time, the IoT would be taking the data and then storing to a XYZ place, and it will make sure that the digital or the 3D model of the physical building is almost in sync. So when I say almost in sync, it knows how many people are there in physical building, what is the strength it is going on, what the temperature it is currently going, it is having, what, how, and when is the AC working. So it will have each and every data live in the real time into the digital twin building. Now, if I want to do any changes to the physical building, rather than straight away going and starting breaking with the bricks and the pillar, how about I just feed that particular information into this 3D model and ask the AI to analyze the changes that I'm trying to do, what is the impact or the outcome, and if there is an impact which is going to damage the building, how it can be handled in a better way. Now these all kind of thing can be done just in front of a laptop or over the cloud with simple clicks. And the best part of this is, whatever solution that I'm trying to implement to the physical building, if I implement same solution to the digital building, and then it would say like these changes are going to make the whole building collapse, I will be very happy that I'm doing a work that's not needed to be done on the physical building. Because in the real life, I'm just collapsing the model. I'm not putting any danger to the physical building. Now, in the other way, let's say if there is no twins model, there is no artificial intelligence, and I directly start working in the physical building, and by the time I realize that I'm trying to do something good, but something wrong has unintentionally happened, I'll end up losing the whole building itself. So this concept is very widely used in a big or the skyrocket kind of building, because the building needs to have maintenance from time to time. and the only way to make sure the maintenance that I'm doing maybe on the ground floor is not impacting the 100th floor, or the construction that I'm doing on the 100th floor is not producing enough stress on the ground floor so that the building would fall down. Now, all these things are taken care by digital twins plus AI. Now, the key benefit for this is I have a virtual representation of the building system. So I don't have to physically go into the building to make sure, okay, what needs to be done and where it needs to be implemented. It's like I have the virtual representation of the physical building, and I can look into that particular 3D model to find out the details, because it's a real time data feed that comes from the physical building, and it always tries to make sure that the digital building or the model that we have created is always in sync with the physical building. The second thing that it can do is, uh, the building doesn't have a mouth, they can't speak. But if we have a 3D model present here and artificial intelligence applied to it, and then we have Internet of Things who takes care of the live data and put that into a real time into the digital twins, it can predict, as we discussed in the previous slide, that okay, if this is how the building works, maybe something going wrong after a specific interval of time, maybe after 6 months or maybe after 1 year, this part of the building needs maintenance because of this reason. So again, it's somehow we are adding ear, eyes, and mouth to a building when we add artificial intelligence to the physical building as well as to the digital twins. The second thing that we already talked about is testing before implementation. Now this is a very serious stuff. Testing before implementation can, many times, or not many times, it will always lead to a successful implementation, because we have tested and we have made sure that whatever solution that I'm trying to implement on the digital twin, the same response will be given by the physical twins as well. So the building is also going to behave in the similar manner, because I have a real-time data, live data coming from there, and then always, sorry, always this digital twin is in sync. So this is about the digital twins and AI. I'll just hold on for a few seconds, and in case anyone has any questions, because these all are very interesting topics as well. So I'll just wait for a few seconds in order to take any questions that you have. Okay, so I take silence as no. Moving to the next slide. So now what we are going to do is, whatever we have discussed in the theory till now, we're going to see how the AI has been implemented in a real life and what is the outcome that we have seen. Now we already know what is the HAVAC system is, so I don't have to repeat. And we also know about the office tower optimization and everything. Now the first case study is how the AI, has changed with respect to the energy when we have implemented an optimized HAVAC system in one of the office tower. So the first challenge that the most of the company, organization, or the country faces, they tend to make a very big buildings, but making sure that they have enough energy supplied to the building and making sure the energy is utilized properly is always a challenge. So the first challenge this case study is highlighting is high energy cost and inconsistent indoor comfort. So high energy cost, we understand that if there is no AI, someone switch on the light of all the floor at around 9 a.m. in the morning, and that light would still be there unless or until someone goes and switches it off. So this is like energy loss, and it is going to cost you. So the solution that we talked about is, let's apply the artificial intelligence in the HAVAC system, like the building heating system, building ventilation and the building AC based on the real time. Now, why do we say real time? Like based on the real time, and some of the parameter that we talk here is occupancy. Occupancy is how many people are currently in the building. Now, based on that, the heating, the ventilation, or the AC can work. The second thing is based on the weather. Like in the June month, if there are, the building is having full strength, maybe during the December, even if the same number of people are there in the building, you might not need to have the AC running with the same speed, with the same frequency, or in the same efficiency as we are expecting it to work during the June or July time. November or December, it's like we can have the AC working in a minimal temperature and put more focus on the ventilation, or maybe have a proper heating done. The second thing is the uses pattern. Uses pattern is all about, and just analyzing the way it says, like a Saturday, Sunday, or any holiday, uh, the building is not operational. So this is like it's a pattern that it will recognize, and instead of just having the minimum light setup done, because it needs to have the minimum light setup done during the office working day, and the moment someone enters, based on the strength, it can lighten up the building more. So it doesn't have to do this minimum lightning, or minimum any other activity that needs to be done. Saturday, Sunday is like realizing the pattern, and then making sure, okay, let's make the building more energy efficient, or as much of energy efficient as it is possible. Now, the outcome that has been seen from this study is that when the AI is implemented in this Havoc system, it has led to almost 20% of the energy saving. Okay, I see some questions. Let me just go to the question. So the first thing that I see is, how does AI use predictive analysis and reinforcement learning to optimize
Yes,
energy
one
in the
question
building?
came, sir.
Yes,
One
yes.
question came by Dr. Mohammad Maqbul Hussain. How does AI integrate with IoT and BMS for real-time control, and what are the main challenges?
Okay, I see two questions from him, I believe. One talks about the AI using the predictive analysis, and second one is IoT and the
The
BMS
same
system.
person is there.
Okay, okay, okay. So, okay, let me talk about this one. So we know this artificial intelligence, and it is integrated with the building. Now, IoT is most of, Internet of Things that we say. Now, let me give a very simple example here. If you enter inside your building, and let's say your apartment is on a fifth or sixth floor. Now, the light in the stairs always has to be on. Now, if you apply the artificial intelligence to it and IoT to it, so IoT, think in a simple term, IoT is nothing but some device that has been installed in the building, which is just collecting your data, and it's connected to Wi-Fi so that it can send the data to a specific place. Let's say it's a cloud, or as you have mentioned, BMS, that's a building management system. So IoT is about collecting the data over the network, sending the data to the BMS. Now, once the BMS has the data, it will have some software, or in simple, it will have the artificial intelligence, which will be trying to, read that data, and then it will try to come up with the outcome. It will try to see if there is any pattern to it, if there is any anomaly to it. So if we, combine these two, what would happen is, let's say you enter the building and you are going to the fifth floor. So it doesn't have to be that the light is always on throughout the corridor or throughout the stairs that you are going. The moment you try to, get into the entry point of the first floor, or maybe the ground floor, there would be IoT, there would be a device. It will detect your presence, and then it will send the data to BMS. Now in the BMS, you have, AI integrated to it. Now the AI would predict, and it will tell that, okay, I have encountered a person who is trying to enter the building. Now, the task that I am assigned is whenever someone comes, I am supposed to send an alert, or I'm supposed to do something. I'm supposed to trigger activity. So it will send a trigger that, okay, we need to switch on the light for the first floor or the stairs in the first floor, so that you just don't happen to fall down. Now, once you are into the first floor, the IoT would again say, okay, now there is no more object, there is no more presence that I find. It will send the information to the BMS, and then the BMS again has some action to be taken care. So it will do that. Okay, since there is no one moving around the stairs, let's switch up the light. Now, by the time you reach to the second floor, again the devices or the center from the second floor will mark your presence. The same circle would happen, sending the data, BMS, artificial intelligence, and then the final outcome is it will switch on the light for the second floor, so that you can move from second floor to the third floor. Now, this activity will continue till you reach your apartment or your flat. And again, once you enter your flat, again you can have IoT installed there. You don't have to maybe open your door. The moment you get, there will be a facial recognition, and it will open the door for you. And the moment you get into your room, from one place to the other, maybe moving from drawing area to maybe dining area, from dining area to kitchen, or bedroom, not all the light of the building needs to be on at a specific time. So the way you move based on the necessity, this particular sensor will read your presence, mark your presence, and then it will turn on and off. And then, as you just have to blindly go or use the apartment as you want. You don't have to worry about trying to switch on the light, trying to switch on the AC, or trying to take care of anything. This is all about how the AI is integrated with IoT, and how does the BMS in the real time controls it. Does that answer your question?
Yes, sir. Yes, sir.
Okay.
Sir, time is 8:48.
Okay. I'll just try to quickly
Okay,
jump.
sir. Please.
Yes. So the first, we talked about artificial intelligence in the Harvard. It leads us to 20% energy saving. The second use case that we have here is, again, it's a predictive, finding out the elevator maintenance for a high-rise building. This I have talked in details. How does it work? All the IoT stuff, maintenance, sending email. The final outcome is, when the AI is added to this particular use case, what it has been noticed that there is around uh, re, reduced elevator downtime by 30%. So downtime is reduced 30% because there is a lot of automation happening. There is no manual work of getting the information that the elevator is not working, passing that information to the concerned person. No, it just within a microsecond, the sensor would detect something is going wrong, and it sends the email to directly the concerned person. And since most of the time the issue is fixed before it breaks down, so the damage is less. If the damage is less, the repair activity can be done very fast, and it comes around that. It comes around that the downtime is reduced by 30%. And what it does, along with saving the time, it improves more safety, and you have the better equipment life as well. The next thing that we can talk about is, since everyone here comes from the educational institute, the AI can also be implemented to educational institute in controlling the lightning. uh, if I just give an example, what could be the challenge? There is a excessive energy that is used, and it's not the lightning is not consistent, maybe in the classroom, as some of you might have noticed, and in the common area. Now, if you apply artificial intelligence, what it will do is, it will try to have the lightning as per the ambience around you. If it's like 12 in the noon, then the light inside the building needs to be much brighter so that you can see. During the night, you don't need to have the light intensity so high. You can manage with the dim light as well. So based on the situation, when the intensity of the light is high or low, is indirectly saving energy for you. Now, when the AI was implemented into some of the educational institute, we have seen that there is a 25% saving in the energy that has been noticed. The benefit for this, again, we have talked about it. It saves the energy, it improves the security, it enhances the comfort, because the moment I get into my building, the AC is on, the lights are on, everything is ready to be used state. So enhancement is, enhance the comfort. And then predictive insight is also good. Like I know that AI is implemented, there won't be any elevator, any lift failure. So this gives me a safety as well. Challenges that we see with respect to this is, first one is the data privacy, because all the data with respect to a specific building would be either stored into a cloud, or it would be stored into a building management system. That's not it's always a challenge. Like if you're sending or storing the data in the cloud, there could be someone else who can hack your data. And once someone is having access to your data, it's almost like they have access to a building. The second thing we have is cyber security risk. Now, wherever there is an involvement of a cloud, there is a cyber security risk as well. The third one is high initial cost. Obviously, if we talk about digital twins, if we talk about sensors or the Internet of Things that would be implemented, these everything comes with a very high price. All these sensors, all these machines, the cloud storage, the management system, everything has a high charge. So it's not easy to maintain this kind of artificial intelligence in a small building. It is useful to maintain this into a commercial building. Now, the last point challenge that I see is a skill gap. So that's the reason you might have heard the whole of the universe is now talking about artificial intelligence, Gen AI. Everyone is crazy about it. The reason for this is there is a skill gap. So there is more demand of the people who knows artificial intelligence or machine learning, or the people who can at least understand the concept, and there is less supply of the people who really understand this particular concept. So there is a huge skill gap, and finding the right person to implement the right solution that you're looking for is always a challenge. There are some of the
Thank you.
okay,
wait. Please,
I
please,
think
please, sir. But this slide is last only for 2-3 minutes.
Okay.
yeah, I'll just take 1 minute to cover it. So now the ethical consideration that we have is the AI is a biased. So AI is all about, it's not a human, it doesn't have intelligence of its own. Now whatever data that you are feeding, it takes the decision. Now if you feed the biased data, then it will give you the biased information. Like if I feed all the information, all the flat in Patna are around 5K, it will tell you that if you go for a very well-known builder, still it will tell that it is a 5K. So it can give you a biased information if you feed a biased data to it. Now its transparency is again an issue. You don't know how it is thinking, because it's all the LLM model, and it would have its own way of processing the data and giving the response back to you. Accountability is also a problem. This you can notice. You just get into the chat GPT, try to type the same question 5 times, you'll see 5 different response. So the accountability is not there. The future trend that we see here is autonomous building management. Like everything, starting from the HVAC system, lightning system, security, everything, the building can be managed without any human intervention. So everything would be taken care by the artificial intelligence. And we can see some of the high-tech buildings in the world, where everything, maybe if I talk about the airport, you have facial recognition. No one needs to take care of security. You go, if your facial is recognized, you have an entry in the airport. If not, you can't enter. So that's like doing automation to the maximum extent. Now, integration with the smart cities, again, if you have the building, you can integrate with the cities. Like, if I can give a small example, you have solar, you have renewable energy. Now, if you have energy when your building is shut down, you can pass that energy to the city. It can be used. So it helps you to, manage the energy in the most efficient way. The takeaway is, again, AI is a game changer. Everyone is talking about it. Generative AI and digital twins is going to rule the market, because there is a less impact on the physical building and more impact, more on the 3D model. Sustainability at the core, again, it's sustainable because we are saving a lot of energy, that is somehow reducing the carbon footprint that we have. Everything, the decision that is taken is the data driven, so there is less chance of any mistake. Like, if you come to the door, it will do the facial recognition and then it will open the door. If you don't get in front of the door, if the face doesn't match, that means the data is not correct, it won't open the door. Now, integration with the smart city also we talked about, and we have reached to the final slide. If you have any questions, please feel free to ask. Thank you so much.
Hello.
Thank you, sir.
Good evening, sir.
Nice presentation. And sir.
Okay. Thank you so much.
Thank you, sir.
Thank you, sir. It is very
Informative session. We learned many things, but because of the time constraint, since we do not know it's 9 o'clock, so maybe this link will be over by 9.
Yeah. I had a plan, but I think,
Anyway, sir, your presentation is very informative, very nice, from Dr. Maqbool Hussain. It is coming nice presentation, sir. And we are getting in the chat box also, sir. And we will share your mail ID and phone number to participants. If in future they have any doubt related to this topic, they can contact you, sir.
Yeah,
Is it
I'm
okay, sir?
always, yes, I'm always happy to help. And I'll share the updated PPT as well. I made a slight modification. So I'll share the PPT so that if it is supposed to be updated somewhere over the server, just to maintain as a
Anil sir is
track
also
record.
telling very informative session. Dr. Prabhu T, very good and informative presentation. Anyway, thank you. Thanks very much, sir. Thanks a lot. Should I close it?
Yes. Thank you, everyone, and thank you so much for this opportunity.